Okay, everyone, we're going to be looking at lesson 55 today. I'm going to go ahead and scroll on down. Go ahead and have your packet in front of you with lesson 55. Scroll down here and get it. Here we go. Okay, and I'm going to add a page here so I can take some notes for you before we start writing into our packets. Okay, so today's lesson is about complex fractions and how we use the division rule for complex fractions. Complex fractions are simply, as stated here, fractions within fractions. So the red line here is actually dividing the numerator from the denominator in each one of those fractions. So you have 4 over the fraction of 3/6. The second one, 2/4 over 8. And 3/9 over 4/12 is the last one. Before we do those examples there, though, I want to go through the lesson a little bit more in detail with you. So if you can remember with me, the denominator, there's a rule called the denominator. I'm trying to write quickly here. Numerator, same quantity rule. We've used this even since our 8th grade math book. But what it says is basically this. If I start with the number 5, just as an example, I picked 5, and I multiply 5, I'll put it over 1, and I multiply that with 2 over 2, it doesn't change the value of 5, right? Because 10 over 2 is just simply another way to write 5. But the denominator-numerator same quantity rule means this right here. So we have the denominator, numerator right here. The same quantity just means that I haven't changed 5. I bumped from 5 to 10 over 2, which means 5, okay? So the only illegal issue that you might have with something like this is if you used 0 over 0. That would be the only one that we couldn't use because we can't have 0 as a denominator. So that would not be something that we could legally use in math. So that number needs to be a non-zero number. Okay, so let's look at the next example here. So I'm going to take a complex fraction, and I'm going to write it just using variables for the moment. I always like to make this line right here just slightly bigger because otherwise you just have all these lines, and I like to know where my numerator and denominator are, even in these complex fractions. Now think through this with me for just a moment. I can't have in this complex fraction, no matter what number I would choose to put in here, the only numbers I cannot use for B, because B is a denominator in the top fraction, and C and D are both in the denominator. None of those could be 0. Okay, so here's how we begin to solve this. So remember that whenever you divide fractions, I'm going to write it out this way because we're so used to seeing and doing them this way. What happens here? If I use KFC, keep, flip, change, I keep the first fraction, I flip the second fraction, and I change it to multiplication. Well, this procedure of solving complex fractions doesn't change that concept. We can use the KFC for this as well. It just looks slightly different, but all we're going to do here is we're going to flip the second fraction, which is in the denominator, because think through this with me. If I multiply by the reciprocal down here in the bottom, look what happens. It becomes CD over DC, right? Which is really 1. So now I've successfully created the denominator as a 1. I've turned it into 1. Those would actually cancel out. I like to just put a big fat X through it. And then we can then we multiply the AB times that reciprocal. That's exactly what happened over here with the KFC method. So let me just finish this out over here. So then I would have my final answer here would be AD over BC. Okay, that's how we solve complex fractions. Let's look at another example, and then we're going to put some in our notes. Let's say I have AB over C. Well, this is a complex fraction because I have a fraction in this fraction, but my denominator is not a fraction. Well, how do we normally handle that? We can always make a whole number a fraction by simply putting it over 1. I'm going to use the same process that I did in letter A's example by multiplying the denominator and the numerator by the reciprocal of your denominator, because that's going to wipe out the denominator. Now everything is up in the numerator, but it's still fractions, right? So we're still going to have a numerator and a denominator here. We would have A times 1 over BC, and we don't have to write the 1, but you would have A over BC. Now let's go up to your notes. Number 1, and these are very small written in my packet. I actually rewrote this little problem. And we're going to solve this one. Now in this case, we have a denominator in the, a fraction in the denominator of this complex fraction, and our numerator is only the letter m. So I would start by putting the letter m over 1, just to rewrite this. So let's rewrite, putting m over 1, and then we have 2 fractions within our complex fraction. Now we want to wipe out that denominator, and we do that by simply flipping this one over. And remember the same quantity, remember the denominator, numerator, same quantity rule says if I multiply my denominator of my fraction with a number, then I have to multiply my numerator with that as well. Because remember, this right here has to be equal to 1. All right, now let's just do the math. So this crosses out, and we're left with mn over 1, which is really just mn. And that's the answer to the first example in your math packet. Now let me go back down to my sheet here. I'm going to continue on with a couple more examples. Let's say we have something that looks like this. Let's say we have 1 over c over 1 over b. Okay, now remember in this case, I have a problem where neither c nor b can be equal to 0, right? Because we can't have a 0 in the denominator of any fraction within our complex fraction. Alrighty, so we're going to want to wipe out our denominator. So I'm going to flip it over, multiply by the reciprocal, and remember to write it up here in your numerator as well. That will take care of our denominator. Let me write this down here. I'm going to continue over here. I'm going to have b over c. When I multiply 1 times b and c times 1, I end up with b over c. Okay, let's go to your math packet again and look at number 2. Same idea. Let's go ahead and look at this complex fraction. We have a over b over 1 over c. So we're going to wipe out, the first thing we do is get rid of this denominator. So we're going to multiply with its reciprocal, but we have to multiply both the bottom of our fraction and the top of our fraction. And we end up with AC over B. Pretty easy. Let's see if I have another example here. Okay, I have a couple more quick examples, and we'll do that last problem in our packet. We'll do some examples together, and you are free to move on to finish up your lesson. All right, let's say we have a problem that looks like this. A over 1 over c. So now I have one fraction within my complex fraction, and it's living in the denominator. Well, we know that we need to wipe out that denominator. Remember, c cannot be equal to 0 in this case. That's the only one. A could be, because eventually that's going to end up being only the numerator in our complex fraction in the top fraction. All right, so we're going to wipe out our denominator by multiplying it. Actually, we want to rewrite this. Let's rewrite this as A over 1 over c, so that we always have two fractions within our complex fraction, because that helps us now when we're multiplying to get rid of whatever's in the denominator of this complex fraction, and we end up with A times C, and that's the answer to example D. Let's look at one more, and we'll go back to your notes. Let's say we have one that looks like this, A over X over B. This one's just a little bit more complex, over A plus X. All right, this doesn't change the process any differently. We have a complex fraction because we have this large fraction that has a fraction in the numerator and a fraction in the denominator. So what we want to do is, again, we want to remove this denominator that's within our complex fraction. So we just multiply by its reciprocal. You see how nothing changes. The procedure works every time. Okay, the only thing that we want to consider here is if we actually had numbers here, the only thing that could not be, we could not have, b could not be 0. What else could not be 0? X cannot be 0, right? And by the way, I find those right here. So b can't be 0 because it's actually in the denominator of our complex fraction, nor a plus x. None of those can be equal to 0. Okay, so let's keep going. So this crosses out because this all becomes 1. B times a plus x over a plus x times b becomes 1. So we can cross that out. I don't even bother taking the time to write 1 and having to rewrite the whole numerator again. I just cross it out. We already have established that that equals 1. So now we multiply these two, but we can just write it like this. We can put it as a times a plus x and not actually expand it out over xb. And that's the answer to that. And you have one in your packet that's similar to this. So let's go back up here and find that. Number 3. All right, so we're going to handle this the same exact way. We know here that x plus y nor w can be 0. Neither one of those could be 0, right? None of these could be 0. Okay, let's wipe out the denominator. How do we do that? We multiply it by the reciprocal. Whatever we do to our denominator, we must also do to our numerator. So we're going to take care of that right up here as well. Oops. Should be an x plus y here. We know now that our denominator on the bottom of this complex fraction actually becomes 1 if we multiply that out. So we can just wipe it right out with the big X. And we end up with x times x plus y all over 2w. And that's how you do those problems. Okay, so as I said earlier, keep in mind, really all of this is the KFC method that you already know. That's what's happening here. It just looks slightly different as we handle it. We've done these before. I don't think this should be new to you. So hopefully you'll be able to work through these quite easily on your own. Let's go ahead and look at A, B, C, and D. Letter A, we have x over m over d over d. That is letter A. Oh, wait a minute. Did I write that out right? X over, let me look at this for a minute. Actually, I think I actually wrote it out incorrectly. Hang on just 1 second. I want to look here. I think I thought that the D was the only thing on the bottom, so I want to check the answer and the answer key really quickly just to make sure. I think I may have written it out incorrectly. I can't quite tell what that is in the book. Well, I have it written. My answer is correct. And I'm wondering, sit tight with me for just 1 moment. I want to try something here. Okay, yeah, it would make the difference. Okay, well, it looks as though this is the correct way. It's funny because in my book this morning, it just looks different to me. Okay, so here we go. So we have this complex fraction. See, that's why I like to make this bar slightly bigger so I know where the complex fraction actually, how it's actually set up properly. Okay, so I have x over m over d. So we're going to put d over 1 so that I know what my fraction, what my reciprocal to my fraction actually needs to be. So we're going to multiply the denominator by its reciprocal and do the same to the numerator here. These two wipe out. I end up with x over md. Letter B. we have 1 over r over, and I make that line slightly bigger. I would suggest you do it too because it can make things look confusing. Okay, we have the same issue here. We have a complex fraction, so we're going to multiply the denominator to wipe it out by its reciprocal. Whatever I do to my denominator, I must also do to my numerator. That's what that whole same quantity rule is about. This wipes out, and we end up with z over r. If you would like to pause the video and work these out on your own and then come back and check just the answers, please feel free to do that. This is for your practice, but I want to make sure that you know that you have the right answers. So go ahead and feel free to do that. Letter C, same thing. We're going to multiply our denominator down here with its reciprocal so that we can wipe it out. Whatever we do to the denominator, we must also do to the numerator. That x's out. We end up with nd over AB. Letter D, we have W over 1 over W plus C. And the same rule applies. We're going to use the reciprocal here to eliminate the denominator. Oh, you know what? I'm going to go back for just a moment because I'm going to rewrite this fraction so I can put this W over 1. Now I can put the denominator down here. You can see they can get a little messy, so please be sure you're writing neat so that you can follow your work, and when I grade it, I can follow it as well. We're going to multiply the same reciprocal up top. These cancel out, and I end up with W plus C times W. Okay, and there's your example problems for you. You can go ahead and start the lesson. If you have any questions, I will be available on Friday from 10 to noon. You can feel free to pop on at any time during 10 to noon. Alrighty, thanks guys. Thanks for watching.